Everyone, this is Chad. This is the step-by-step guide for Cloudblock when deploying on DigitalOcean's cloud. You should have gone through the step-by-step prerequisite video and have a DigitalOcean account already. Let's get started. I'm at the GitHub page and I've got PowerShell open. Scroll up to the DigitalOcean or DO directory and then scroll down to the DigitalOcean specific instructions. We'll need to have PowerShell open and start Windows Subsystem Linux, and then cd to our home directory. Install the CLI tool. Let's grab these commands. I'll grab all three at the same time, paste them in with a right click. We'll give this just a moment. And then for the final command, we hit enter and enter our sudo password. That's the password that we set up in the previous video. Next, we create a personal access token and a spaces ID and secret. So a personal access token is how your command line, Windows Subsystem Linux, talks to DigitalOcean. This URL, I've already got it open here. And we need to generate a new token. I'll enter a token name, I'll call it Cloudblock. We need both read and write. I'll hit generate, there's the token. This is a secret. Keep that in mind, keep this secure and safe. I'm gonna delete this at the end of the video. And then we also need the spaces ID and secret. So I'll generate one of those as well. And I'll call that Cloudblock too. Don't close this page, otherwise you'll lose the secret. And there we go, I have my two sets of credentials. Auth init for DigitalOcean CTL. Please authenticate by entering our access token. We grab the token. I left click to copy and then right click to paste. Enter. Token is validated. And then we add the personal access token and the spaces ID and key to do.tfvars, and we'll do that below. So we cd to our directory, and then in Windows File Explorer, we're going to go to the same directory. So I'll open File Explorer, paste that in, and keep in mind, I've got my username here, Chad. You'll need to replace that with your Windows Subsystem Linux username. Mine is Chad. If you don't know your username, type in who am I, and then just make sure to paste and replace that. The file we're editing is do.tfvars. Double click it. It will prompt you for an application to open it in. Notepad is fine. I've already done that. It's not going to ask me. And we will edit it. So I'm going to go back up here. We note that we need to add the ID and key, and that you can see that here. So let's do that first. So I'll copy the storage access ID, paste it in between the quotes, and the same thing for the secret. Let's go back to our instructions. There is a variable section, phpassword. That's the password to access the Pi-hole web UI. Make it something unique, secure, and safe. For the tutorial, make it fairly straightforward, change me 1A. For the SSH key, that's the key we generated in the previous video. You can get it with this command. To copy from PowerShell, you highlight and then right click, and then paste it in between the quotes. Management CIDR. This is the IP range that's granted access via SSH to the machine that we're creating in DigitalOcean's cloud. It's also granted access to DNS of the Pi-hole without WireGuard, right? So typically, if this is like a home deployment, you'd make this your home IP address, and you could access it from home as long as your home IP address doesn't change. If your home IP address does change or changes often, WireGuard is probably the way to go. And what I might suggest is a hybrid approach where you've got a Raspberry Pi running Pi-hole at home or a small virtual machine, and then you've got a backup in the cloud. That might be a better idea. Or you can always use on your Windows, Mac, Linux devices, your Android phones, iPhones, etc. You could just have the WireGuard app running, and that would work fine too. So I'll set mine, management CIDR, and you will need it to run the initial commands. Keep that in mind. So I will type in what is my IP. And of course, I've got Bing. Everything's default on this machine here. But Google would tell you as well. Replace the first half of that before the slash. The slash 32 means a single IP address in IPv4. And then we need the token, storage access ID, and storage secret. We already set the access ID and secret for storage. Let's go back and grab that token. And where do we put it? Oh, there it is. Between the quotes. Let's look at a few. So those are the things that you must change. Let's look at a few other things. We've got the WireGuard peers. This is the number of peer configurations or VPN configurations to generate. You need one per device. So if you've got a phone, a tablet, and a laptop, that'd be 3 devices. If you're sharing this with others, there's no harm in having more than you need. So 20 is fine if it's just a couple people. You could certainly set it higher. I would say somewhere around 200, 250 is probably the limit. DoE provider, DNS over HTTPS provider. There's a list of options to choose from here. And it might be good, if you're not familiar with these, to do some research on which one might be best for you. I'm going to leave it as OpenDNS. OpenDNS is fine. They are US based, but maybe do some research on which one works for you, where you're located in the world. That might be good. And I'll show you in the diagram. If I scroll back, actually hit back here and scroll down to the instructions. So when you talk to your Pi-hole, you're going to get your DNS back and it's going to block add domains. If it's not a blocked domain, where does your DNS lookup end up? And that is this little cloud over here via encrypted DNS over HTTPS. Generally, DNS is not encrypted. Plain DNS is not, but we are encrypting it, and these providers are compatible with encrypted DNS over HTTPS. So that's what that is. That's where your DNS lookups eventually end up. They have to end up somewhere, and why not use security encryption to do so? All right, what's next? Let's go back to our instructions, and we'll continue down this list. So we've got our DoE provider. Next, we need to determine what kind of client configuration we want to generate for the VPN. You have 3 options, and they're all almost the same. There are some differences, so keep this in mind. The first one is DNS. That's the default option. What that means is all of your VPN traffic, when you've got the VPN turned on, is only DNS goes through it, only your DNS lookups. That will give you the ad blocking, that makes sure your DNS lookups are secure. But that's it. If you were to watch Netflix, it's not going to go through the VPN. All of your traffic, none of it's going to go through the VPN except for your DNS lookups. If all you're looking for is ad blocking with Pi-hole, this is fine. This is perfect. If you do want to use the VPN for all of your traffic, your other option is all. And then there's a third option for those that are interested. It's peers, where you can talk to the other devices that are connected to WireGuard. Okay, keep that in mind. So if you had a device at home, a server, you had it connected to WireGuard, it was a WireGuard client, and then you're away from home on your laptop, you connect that to WireGuard as well, they could talk to each other. And then the final thing I'll mention about this is just client configurations. You could manually set any of these settings after the fact. You could change this on the client. There's no restriction involved. This is just how it's generated. Makes it a bit easier to set up, depending on how you want to do it. All right, so I'm going to leave it as DNS. I just want the ad blocking. That's fine. And then we've got down here DNS_no VPN. So if you remember, I mentioned management side, we use that to SSH or connect to our server in the cloud. And that's our home IP address, typically, if it's a home deployment. If you have this set to 1, again, that's the default, you can also talk to the Pi-hole directly without WireGuard. So I could go into my home router, and I'm going to get an IP address back once we deploy this of my server in DigitalOcean's cloud. And I could go into my router and set the DNS to that server's IP address and talk to the Pi-hole directly without WireGuard, which is kind of nice. It's a good option. If your home IP address changes often, this might not be super useful. I'll leave it as default. Mine doesn't change too often. And then we have the same thing, similar to management cider. If you have other devices or other like other connections from your ISP. Maybe you have a home office that has its own internet service, or you have a friend and they have their own internet. You could, and they don't want to use WireGuard, you could set up additional IP addresses for clients to connect to DNS without the VPN. Next are regions. So you could choose new regions. You do need a region that supports object storage. And at the moment, at the time of writing this, only these regions do. I'm going to use New York City. That's the closest one to me. And we also need to set the version of Ubuntu. You could use 20.04. That does work, but I'll stick with 18.04. It's well supported for several years still. Next, we have the size of the server that's being created. This is the smallest one that DigitalOcean offers. It works fine for me, works fine for this project. You could look at scaling it up. It's going to cost a bit more money per month, but if you're interested in higher performance or something that comes with, it may be worth your while to upgrade it. Next, we need to set the CIDR or network that's going to be used in DigitalOcean. You would change this if it overlaps any of your other networks. So maybe you've got a complex home network and you happen to use the 10 dot network or something similar where you have an overlap. You could change this if you needed to. This is the network that's created in DigitalOcean's cloud. Or if you have additional stuff in DigitalOcean already. We have the prefix. This is a label that gets applied to various resources. You could change that if you wanted to. I would keep it short. If you've cloned the GitHub project, you've made your own version, or you have your own branch that you want to use, or your own fork that you want to use, you could change the URL for the GitHub project. We also have the VPN CIDR. This is set to worldwide because the VPN has authentication built in. If you wanted to restrict it for some reason, you certainly could, but I would suggest leaving it as all 0/0. And then the Docker container network, or IP addresses as well, and the WireGuard network. Again, all these really only need to be changed if they're going to overlap with something that you already have. They probably don't. Unless you're running a business or you have a large lab, something along those lines, you probably don't need to change anything here. The only thing I will change, because I already have things in DigitalOcean, is this CIDR, and I'm just going to change it to 10.10.20. Just to make sure I don't overlap. Okay, everything's been done. I'll save it, close it out, and let's continue. Scroll back down. I've edited the file and saved it, and now we'll deploy. We need to make sure we're still in that directory. We are, but I'll double check. We initialize Terraform. This tells Terraform to download any DigitalOcean specific code that it needs. Should be pretty quick. There it goes. And then this is where the magic happens. This is where we take the code included with the Cloudblock project, the variables file that we just customized, and we tell Terraform to run the deployment where we apply. It's going to spit out a plan. We can see that here. There's a plan to add 10 devices, or 10 things, I should say. And we can look at those if we scroll up. For example, there's a random string that's generated, a local file. The VPC, or virtual private cloud, that's a network in DigitalOcean, our SSH key, a bucket for our backups, etc. So you can go through all those. I'll type in yes to continue. And we'll give that just a bit of time to create. It should be fairly quick, but it does rely on Terraform building all of those resources in DigitalOcean's cloud, and that depends on how busy DigitalOcean is at the moment. So I'll be back when it's done. We'll note there are outputs from Terraform when the apply is complete. So we'll get those. They should be in green. Oh, there they are. And then we also need to wait for the virtual machine to become ready. Ansible will set up the services for us. This is super important. So if I go back to the diagram one more time, in this little box here, we've got Terraform plus Ansible. Terraform builds the resources like the DigitalOcean server, the DigitalOcean network and firewall rules, the bucket that will store our backups in. All of that is done through Terraform, and then Ansible configures the server that's running in DigitalOcean. It installs Docker, the WireGuard container, the Pi-hole container, the Cloudflare container, etc. Configures all of our customizations. So let's look at the instructions, the output. Because DigitalOcean doesn't support 100% automation, well, it does in a way, but it's not, there's no way to store secrets like our Pi-hole password. We're going to do it a little bit manually. So if I scroll up, the first step for installation is to copy via this command the setup instructions or the setup script. So I will try running that. Let's see what happens. We got permission denied. That's okay. That was expected. We need to wait just a moment for the server to fully boot up. It's not done yet. Let's give it like 2 minutes. You could try this occasionally, try it again, and eventually you'll get it. I'll be back in about 2 or 3 minutes. Okay, I was able to transfer the file with SCP. And if we continue, we should have, let me run terraform output again. So if you ever lose your outputs, by the way, and I would suggest saving them, put them in Notepad, you can, as long as you're in Cloudblock /do, kind of hard to see there, but as long as you're in that directory, you can run terraform output and get the output again. It's not in green this time, but it's there. So again, I would suggest make a copy of this, put it in Notepad. All right, so for the installation, we've copied the file, and then next we will start the installation by running this command. So again, to copy, highlight, right click, and then paste with the right click as well. Hit enter, and we'll let this start. Okay, the installation is now going through. We can, if we want, watch Ansible set up the virtual machine, and I'll do that. So we see here, we SSH to the virtual machine. I'll grab that. And then we can run this command to tail the log. And there we go, it's running. So we'll give this a little bit of time to run. At the very end, we'll see something similar to this play recap at the top. We'll give that just a bit. I'll be back when it's done. Okay, that was pretty quick, and we have the play recap at the very end. We see everything's okay. Really, the big thing we want to look for is failed equals 0. That means nothing was failed, nothing stopped the playbook from running. So Ansible is done. Our services are up, and we can see that if we run sudo docker ps. Everything is good to go. We have our containers. And just a quick reference on the containers, we have a secure web proxy. That's the Apache HTTPD server. We have WireGuard running, the latest one, the latest container image. Pi-hole, also the latest. And then Cloudflare DDo, that's a Docker container that we build based on the official Cloudflare GitHub release. All right, so I will exit, and I'm going to run terraform output again because I didn't save it. So let me scroll back up. And we look web UI. This is the web UI for our Pi-hole service. So I will open a new tab. We have a connection isn't private. You'll need to hit continue. That's okay. That's because we're using a self-signed certificate. The connection to our web server is still encrypted and secure. Let me turn off Dark Reader as well. All right, and you'll notice as well, this IP address, this is the IP address of your server. So you could set this in your router for DNS as an example. So I'll log in. That was my password I set. Change me 1A. I don't know why that's popping up. Thank you, Edge. And you can configure it as you desire. The only thing I will mention is if we go to settings and then DNS, you'll see these two IP addresses here. They end in 0.2. That is the DNS over HTTPS service, the Cloudflare container that we're running. That's this guy right here. So if you change that, you're going to lose Cloudflare DNS over HTTPS. Keep that in mind. All right, you could change anything else, add your ad list, etc. What else do we want to do? We can look at the WireGuard configurations. I'll copy this, open in a new tab, and you'll see this goes to DigitalOcean. This is the bucket where DigitalOcean stores our data. We have all our peer configurations. So I had 20 peers, and there they are. If I click one, We can see there are 4 files for each one. Generally, you would either need the .conf or the .png. The .conf is a text file. You could use this to import it into Windows, into Mac, into Linux. And then the PNG is I'll show this as a QR code. You can download it. And if you have the WireGuard app, which is free, and you install it on Android or iPhone or an iPad or tablet, there's an option in the WireGuard app to add a VPN via QR code. It'll open the camera. You point the camera at this image, and it's then installed. I do suggest that you keep a list somewhere, maybe in the same notepad that you wrote the Terraform output in, a list of which devices are which peers. So maybe peer 1 is your cell phone, peer 2 is your laptop. Keep that just so you have a way to reference which is which. Don't get them confused. If you give the same peer configuration to 2 different devices, likely what will happen is that one will work and one will not if you have them active at the same time. All right, and that about wraps it up for DigitalOcean. You've got WireGuard, you've got Pi-hole. You can customize Pi-hole as needed. We have the files, updates. So assume there is an update to Pi-hole and you're interested in it. You do not, if you're familiar with Pi-holes and you've run one before and you didn't run it in Docker, it's worth noting that the update path is a little bit different. Because we use Docker, we can essentially destroy the whole thing, destroy the container, and then rebuild it, and all of our customizations will still be there. We don't run the Pi-hole up or -u or -update command. We do it a little bit differently. That's okay. It's really simple to do, and I'll show you that. So updates, and I suggest at a minimum a frequency of maybe once a month or once every couple of months, in case there are bug fixes, maybe there's a security issue that needs to be fixed, something along those lines. It's worthwhile to do it at least every couple months, or if there's a new feature that you're interested in. So updates. The first step is to SSH to the server. Let's scroll up, and then we've removed the containers. So again, there were 4 containers. That is the DNS over HTTPS proxy, the Pi-hole, the web proxy for secure HTTPS, and then the WireGuard container. So we'll copy this command, paste it in. All 4 of the containers have been destroyed. The service is down until we rerun our installer. And we rerun it via this command, sudo systemctl, and then the service, the Ansible service. That'll start. You could watch with the same output. You could watch this run again, and you can see it starting back up, and then wait for it to finish. And that's about it for updates. And finally is destroying the project. If you're done, you don't need this project in DigitalOcean anymore. We can use Terraform to destroy it, but there is a prerequisite, and it's fairly straightforward, not too difficult to do. I'm done, so I'll destroy my project. First things first, we'll need to empty this bucket. So I've got this bucket open, and it has the WireGuard peer configurations in it, right, for all 20 of the peers. It also would have, if this ran long enough, it would have backups for the Pi-hole settings if you've configured any, and it would have backups for WireGuard itself. So just keep that in mind. We need to clear this bucket out. You could do it manually. That is certainly an option, but it's a little bit easier, especially if you have a lot of peer configurations. It's a little bit easier to do it this way. And this will ensure that all of the objects in the bucket have been removed. You'll need to install the AWS CLI, and we'll use that because DigitalOcean, their object storage, uses the S3 API, and that's something that Amazon or AWS created. So they already have a tool that we can reuse for DigitalOcean to talk to storage, to talk to the bucket. You'll need to run these 2 commands, run them individually. I've already run them. The first one is a sudo command. You may be prompted for your password, and then run the second as well. That will prompt you to install the AWS CLI via pip. And then you can run all 3 of these at the same time. I'll run all 3. This will remove all of the WireGuard configurations and any backups that I have in this bucket. Give it just a moment to run. There we go. And if I scroll back up, the final thing is terraform destroy with that vars file. We have an output from terraform. Do you really want to destroy all resources? I'll type in yes, and terraform will begin destroying. And then finally, the last thing I would note is you might want to go back to your API tokens and destroy those as well. If you're not going to use them again, it makes no sense to keep them around if you're not using them, and then maybe create them if you're going to start a new project in DigitalOcean. That wraps it up, everyone. If you're interested in reaching me, if you have questions, ideas, comments, concerns, you can certainly do that through GitHub, though my suggestion and the best way to reach me is through the Discord channel. I'm active there. You can ask questions. If you have ideas, that's great too. Discussions, there's a lot of great folks that have already joined. And here's the link on the GitHub page. It's also in the YouTube description of this video. Thank you, everyone. Take care. Have a great day.